Alright, in this video we're going to take up yet another example on how to solve problems involving Newton's laws. Let's talk about this problem. The question says that you have a wedge which is at an angle theta. There's a pulley on this wedge and the pulley is massless. It is attached to a 2 kilogram object, and here we have a 1 kilogram object. Alright, so we need to find out for what value of theta will this system will remain at rest. That's what we need to find out. So let's try to do this. First of all, given to us is the fact that everything is a smooth surface. There are no frictions involved. Alright, so we can forget about frictions here. Everything is smooth. So first of all, let us try to draw the free body diagrams. The 2 kilogram object looks like this. The contact is here. When we say reaction, normal reaction means perpendicular to the surface. So it is actually perpendicular to the surface. So therefore you'll draw a reaction like this, N, going upwards. This is the reaction from the wedge. There is a weight mg which is acting downwards, and a tension. Tension is always away from the object. So these are the three forces acting on the 2 kilogram block. Now we talk about the 1 kilogram block. 1 kilogram block is pretty simple. There is a weight 1g and a tension upwards away from the object. Okay, that's 2. Alright. So these are the free body diagrams of our two masses for this problem. Now how do we solve it? The way to solve it is trying to find out what is the value of tension. The tension is holding the 1 kilogram block, and the tension is also holding the 2 kilogram block. So from the free body diagram of 1 kilogram block, we have T minus 1g, and assuming it doesn't go anywhere, equals 0. So T equals 1g. That's our first equation. This is what tension should be if the masses do not move. But how do we write this thing for the 2 kilogram? This is not straightforward. How do we do this? Well, the way to do it is to resolve the forces along the incline, that is perpendicular to the incline, perpendicular to the wedge, and parallel to the wedge. Normal force or the normal reaction from the wedge is already perpendicular to the wedge. We don't need to do anything with that. Tension is parallel to the incline. We don't need to do anything with that either. But this weight 2g is neither perpendicular nor parallel. So we need to first find the components of this weight along the incline and perpendicular to the incline. So let us try to do that, and the way to do it is, this is our mass and this angle is theta. Now we draw a perpendicular to the surface. This would be the weight. This is 2g. If this angle is theta, this angle is going to be 90 minus theta, because this is 90, so this angle is 90 minus theta. 90 minus theta. If this angle is 90 minus theta, then this should be theta, because the line ON is perpendicular to the surface of the incline. So now we can have our components. The component that is perpendicular to the incline will be here, and that would be 2g cosine theta. The component which is parallel to the incline would be here, and that would be 2g sine theta. So that means from the free body diagram we have t minus 2g sine theta equals 0, because the 2 kilogram object is not going anywhere. So from here we have t equals 2g sine theta. Now t is also equals to 1g. So this implies 2g sine theta equals 1g, because tension is same. It is one and the same thing. So from here you can find out the sine theta will be 1/2, or you can say that theta would be 30 degrees. So when theta equals 30 degrees, the system remains at rest. In incline problems, you first find components of forces perpendicular and parallel to the incline, and then solve it. This is the most effective way to solve it. So taking a recap of this, first of all we drew the free body diagrams, we had our equation for tension, this was simpler. After that we needed to find a way to find the tension for the 2 kilogram block. The way to do that was to resolve the forces perpendicular and parallel to the incline. Anything that's parallel to the incline will not be touched, it will remain same. So T is parallel to the incline, nothing was done to it. The normal reaction N is perpendicular to the incline, nothing was done to it either. But this weight, this is acting vertically downwards, not perpendicular to the incline, it is acting vertically downwards. So we have to find the components of this weight which are perpendicular and parallel to the incline. The way to do that was identify the angle, and certainly you can say this will always be theta. So you don't have to find this every time. The component of weight parallel to incline would be mg or 2g sine theta. Component of the weight perpendicular to the incline, which will be acting downwards, and that will be cosine theta. Once we had this, we wrote the equations for the 2 kilogram block, the tension and 2g sine theta, then opposite direction, and if 2 kilogram block does not move, tension must equal 2g sine theta. Then we compared these two values because they have to be same, and we found out sine theta equals 1/2, or theta equals 30 degrees. I hope the problem is very clear. We'll take a couple of more examples, so please check them out, and thanks for watching this video.